Well, are you interested in another variation of path virtualization? Let's take a look at IPsec.
You're watching IT Pro TV.
You may have been with us in a previous episode. Anthony was over there. Ronnie was over here. We're mixing it up. Ronnie has volunteered to walk us through the IPsec configuration and verification. This one is lengthy, right, Ronnie? But I guess if we break it down step by step, not too bad.
Yeah, it really depends, but this is one of the longer configurations that we have to deal with. And Anthony, I remember first times when I really got it set up, it was probably the longest configuration I'd ever done at the CCNA level when working through my CCNA security. And I felt like celebrating after I actually got 2 routers to do this, because the configuration, once you finish one side, you're like, wow, that's great. And then you go, oh, I have to do the other side. And at that point, you feel confident that since you already set up that first side, you can go to the second side, and it's going to be exactly the same. And Anthony, that second side almost just tore me apart when I was trying to remember what to do.
And it's no surprise either, Ronnie, to me that there's often GUIs, right? You know, this is where like a graphical user interface you'll often see used, because it'll put all this in for you and reduce your chance of error.
Yeah, and that's pretty much the key, right? So a lot of times when you do see this, it's easier to use whatever GUI interface that you're doing. So I was used to also trying to go through that Cisco Configuration Professional that came along with what you could actually get for the routers to be able to do this. But sometimes you just have to know the commands. And Anthony, we're going to set this up and show you at least one side of the configuration. The other side is essentially a mirror, which I've already set up. But this will help you to understand the pieces that are involved in getting an IPsec tunnel connected in the way that we need to.
Cool. And we're doing like a point-to-point example here of just basic IPsec, right?
Right. So we're not adding in any additional flavoring to this. So we're not going over like dynamic multi-point configurations or anything. But we're just doing a basic IPsec connection, which involves a couple of different elements. But it's multiple commands, so you do want to pay attention to this. And of course, the goal is to make you feel confident when you're doing this. So let's go ahead and jump into the diagram, and that will help us out as we get started. And what we're going to be focusing in on right over here is going to be between router 1, which I've already labeled as R1, and also this other router over here, which I've labeled as R2. Now, the great thing about using the Cisco Viral, if you click on it, so if you actually click on it, a little bit of a technical glitch there. You click on it, you actually see the interfaces, and those are the 2 interfaces we're going to be using. I matched them up so it's actually easier for the configuration. If you can do this inside of a lab setting, then it really does help you out when you start to actually take a look, and that way you don't have to try and figure out like what interface did I do this on.
Okay, gotcha. Yeah. So you made sure that the Gigabit Ethernet 0/2 was connected to 0/2.
Right. It just made it easier for me. In a lab setting, you'll be able to do that. Now, in a real setting, probably not so much so, okay? So I've set up this particular little subnet for us, which is 192.168.12.0, and I've labeled one as .1 for router 1, and the other end as .2 for the other side. So from that point, I've set up, well, essentially the other side, which is on router 2. So we're just going to be configuring this side, and everything that you do on this side, you're pretty much going to be doing on the other side, except for a couple of different places. And either I'll point them out, or if I miss it, Anthony will point them out for me.
Awesome.
And that will help us out as we get started. So let's go ahead and jump into this. I'm going to switch on over, and we are connected over here. And you can see, and I'll zoom this in so that we can see it just a little bit better. So as we get started here, we're going to be on router 1. And of course, I just want to make sure. And my typing is nowhere as good as Anthony, so we'll actually kind of get started here. We'll go into our global configuration mode. From there, just into the, actually I don't need the gigabit interface yet. We need to go ahead and set up what we call, of course, the policy here, okay? So when we set up the policy, it begins with crypto, ISACamp, policy, and I'm just gonna do policy 100, okay? Now that number at this point doesn't really matter for us, unless you have multiple policies, right? When you have multiple policies, then it begins to matter a little bit more. I just set it up as 100. And I think that may be the default if you don't try to set up a number anyways. But most people set up 10 when they're doing a lab. I just like setting up 100 because it just makes me remember.
Gotcha. And that's a priority number.
Yep.
If we had a bunch of them.
Right.
And lower is better?
Yep, lower
Okay,
is
gotcha.
better. So there's sometimes when you see that, I like setting this up, especially if I'm doing it, like 100, I'm going to be creating an access control list, and that's going to be where I begin with 100. So I like keeping numbers consistent. It just makes it easier in my head
Okay.
as I start doing all this. Now, when we start setting up the policy here, the easiest way to remember this when we set up a policy, Anthony, at least for me, is remember an acronym. So I like using these acronyms. I always say, if we're going to set up IPsec, we need to begin with haggling, okay? So what the heck do I mean by that? So I'm going to actually do hashing, okay? So I need to set up a hashing algorithm, and I'm just going to choose MD5. Now, Anthony, would we ever really choose MD5 in a production environment?
Probably not. We want something even stronger.
You do want something even stronger, but since we're only doing this in a lab environment, and the key and the goal for us to get it set up and working, I just recommend setting up the easiest one that we can do, and this is one that you'll remember. Okay?
So you're kind of doing lowest common denominator thing to make sure you don't blow up your lab environment.
Yeah, and so if you happen to do this on GNS3 on your own lab machine or on your own laptop, you might see that it becomes a little bit resource intensive as calculating through and doing all the other stuff here. So like setting up to verify that it's only the tunnel that I'm worried about. Now, since we talked about haggling here, the next step is authentication, and we're going to set up a pre-shared key. So HA, and now we need a Diffie-Hellman group number, and I'm just going to set up 2. Now, there's a lot more than that. Let me show you what I'm talking about. Now, just when I say this, I think there's even more numbers than this now, if I remember correctly. Now, I may not, but at least at this point here, I'm just setting up kind of the 1024-bit, trying not to challenge the system that I'm on right here. But on real production networks, of course, you might set up at least group 5, if not all the way up here to group 16 or 14 or whatever else it might be. But that will be set up for you, or somebody will tell you what that's actually going to be when you need it. Okay, I'm just going to do a group 2. So HAG, now there's always a lifetime that is also set up. Now this is the actual connection in the terms that this tunnel is going to last. The default here, if you don't set up a lifetime, 86,400 seconds, which is a 24-hour day if I remember right. Okay, now you can do that. You don't have to set this up. And I just like setting it up for 3,600 for an hour. And I can set it up for less if I like seeing the tunnel kind of go down and then see, try and bring it back up. Setting it up for 24 hours and going, all right, so how can I have to actually manually break it down and then make it come back up if I want to see that. So in lab setting, I always set it for less. Okay.
Gotcha.
Now, the neat thing is if you're setting this up as side that's really going to be in command of everything, the other side that connects, you normally have to set up as less than whatever you set up here. Now it can be equal, but it shouldn't be more. So once, so if you're actually going to be, say, this is your primary side that you're actually going to be configuring, you want to set this a higher value than the other one or make it exactly equal.
Okay.
Okay. All right. So Anthony, HAGL. Okay. So in IPsec, we remember that the last part of that component is encryption. Okay. When we actually set all those things in order, so we actually do type in the word encryption.
I love your approach there. What a clever use of an acronym to make sure that you're hitting all those configuration steps under the policy. I love it. And that's like so CCIE.
Yeah, because if you don't, okay, Anthony, we know this because we've done it so many times. You forget one of these.
That's right.
And the other side, you did it.
Right.
And what happens? You don't get anything.
Yep. And you're also taking the variability out. Something else I like about this is you're taking the variability out about which you do first.
Right.
You're like, all right, I do it in this order and I make sure I get it done.
Yeah. So now that we've got that set up, we're going to really kind of go back to that A for a moment, that pre-shared key idea, and we're going to configure the key that we're going to be sharing with the other side.
Okay.
So this is where we do crypto, and then we do ISACamp here, and we say we want a key. Now, this key is going to be one that you actually do come up with. This is going to have to match on the other side. Okay. So we're going to use our very basic, I actually did a Cisco 123 and just make it 8 characters long. Then we need an address, okay? Now, when we start talking about the address, notice the way that's described here in the help is the peer side. So don't set it up with the IP address on your own interface that we're going to be doing. We're going to set this up with the IP address on the receiving interface that we're hoping to connect.
Okay, so this is that first spot where we have hit where you'll doctor
right.
the IP address. So That right there, you're putting in 192.168.12.2. That is the IP address on who we're going to peer with.
Right, which is router 2.
Yep. And router 2 will have the appropriate address of router 1 in its config.
Yeah, and that's where there will be a change in the configuration. That address right there is the first change that we'll see if we were configuring this over on router 2 on the other side. Now, Anthony, as far as ISACamp goes, okay, that we've set up, that pretty much is it. Now, the problem that we have is we're doing an IPsec, which means we not only need this initial side of things to actually be configured, we now need to go to the IPsec side to begin to configure this as well. Okay?
Gotcha. So that first kind of configuration, we're working on that tunnel that's done initially so that then we can exchange the information to do the security of the data.
Yeah, and that makes sense, right? So if you've learned about the IPsec tunneling theory and terminology, right, we create two different types of association, right? The initial side, which allows us to form that kind of tunnel, but then we actually form the tunnel that allows us to pass traffic through securely.
Sure.
Okay. So the way that we do that is we actually set up with here IPsec transform set, and we can give it a name. Now, this name, it doesn't really matter what you actually name it. It's going to be locally significant to this router, but it always is helpful if you actually are at least logically consistent with how you want to set this up. In other words, don't name it something cryptographic like ABCD. Okay? Don't name it side 1. I guess that could be, depending on how many that you have. But I always like keeping like the router, and then I just call it set, R1 set. And that way I know that it's part of the transform set that I need set up.
Yeah, I love that. And you and I do the same thing. This makes me so happy. I thought I was one of the few people that did this.
Yeah.
Whenever you're naming something, you use all caps, don't you?
Yes.
I've always done that.
And that was just a best practice I've learned actually not only from reading blogs, but even in Cisco Press books that I've read or in other Cisco books that I've read. It makes it, in other words, I actually understand that it was something that I set, not something that the router itself has figured in there.
Yeah, exactly. It jumps out. It's not a keyword. It's something you set. And I love it for this reason too. A lot of times people get, well, is that case sensitive? And I always go, I don't care.
Yeah.
Because I'm always in uppercase.
Right. Now, once we have this, right, we need to now tell it how we're going to do this. We're using ESP, encapsulating security payload, and we're going to say we're going to use that MD5 hash, and then it's going to fill it in, and you see the list up here above. And I'm also going to tell it, and I believe I chose triple des is what I ended up choosing. Okay?
Sure.
So there's the transform set. Now, I think Anthony and I, we were talking about this before the episode here. So when this actually gets set, we might not need to set anything at all, but Anthony, I'm always paranoid about this.
Yeah.
So I always go ahead and I tell it what mode I want to set, which is transport or tunnel. Okay. So this is up to you at this point. Let's see if that comes back. There we go. Okay.
We're gonna make it through this episode, and just barely because we have a faulty connection. Looks like we're gonna make it through.
Yeah.
So I love what you did there, Ronnie. So there's a very good chance, in fact, I know it does. It defaults to mode tunnel, but again, you take memorizing that right out of the equation by setting it.
Yeah, and I don't want to assume that it's going to be set.
Sure.
I want to make sure, and this way it shows up in the running config. If I'm doing some debugging at that point, I know I set it. I'm not counting on the default here. I want to make sure that I do that. So now we have that transform set up. We now need to make sure that we configure, let's see, our next step here is the crypto map, if I remember correctly.
Yes.
Okay. All right. So what in the world? Okay, so Anthony, I'm going to actually count on you here.
Sure.
When I actually talk about the idea of the crypto map, I'm trying to join a couple of things together, aren't
I? Absolutely. Okay. You can go ahead and type it in and I'll talk through it. So yeah, this crypto map is key. Notice that the first thing Ronnie's going to do here inside that crypto map is he is going to indicate who he's going to tunnel with. So this is the second time we've had a variable that will change. So he creates his map. Notice he names his R1 map, sticking to his naming convention. He's all uppercase. And then he's going to go in and he's going to set the information on who he's peering with. And this is going to be that IP address of R2 because we're configuring R1. Got to remember to mirror that, flip that around on the other side, which again, he's already configured for us.
So this is neat because of the note that it really gives, and literally as actually says note there, right? New crypto map will remain disabled until a peer is actually valid on the other side as well. So we want to make sure that we go ahead and we set a peer, And this, oh, too many E's there. Here, 192.168.12.2.
Yep.
See, I almost made a mistake there. So hopefully in just a moment, it's actually going to come back up. So we make sure that we set the peer. Now, this is where I made a mistake, Anthony. Okay. Now, I say a mistake. I know that we can add this back in a little bit later on. I need to actually say what's going to end up matching here. And I was supposed to set an access control list. Okay. So that was something that I did kind of, but can I do it later? Well, let's see if we can. So I just type in match, which I forgot. So we're telling it we want to match. And I told you I was going to keep this as 100 here. Okay. Now.
So that's an access control list reference that will dictate what gets encrypted, what's going to use the tunnel. And Ronnie pointed out that he hasn't created ACL 100 yet. So he went out of order. Let's see if the router will let him do it. And then the other thing Ronnie's done here is, as he promised, this ties things together, the crypto map. And you can see it's how he brought in his transform set called R1 set that he created earlier.
Yeah. So that actually kind of ties everything together. Now, Anthony, once we get all that tied together, last thing that we really need to do, actually, I need to go ahead and set that access control list, or I'm
You better,
really,
yes.
Yep.
And that's why Ronnie does like to normally, he creates that access list before he references it. That's a best practice. If he says, oh yeah, I'll create it later, the feature might not work.
Yeah.
Or oftentimes he's going to forget to create it. So it looks like, Ronnie, you want this thing triggered for traffic from quad 1 going to quad 2.
Yeah, and the reason why I did that, I set 2 different loopback interfaces, which I did forget to mention at the beginning of the episode. The quad 1s are over on router 1. Quad 2 is on loopback over on router 2. So I'm pinging through the tunnel that I'm making from a loopback interface to a loopback interface. And this is what sets my interesting traffic. If you go and read the terminology, is what hits the interface and says, a tunnel is supposed to come up. Everything's actually supposed to happen at this point as well. Okay. Now, there's really only one command left at this point. But before I do that, okay, that one command, I'm going to do debug crypto ISACamp, and that's enough. And then debug crypto IPsec. Okay. Now, I'm going to turn this on because this is the initial verification that I really do get that shows me a lot of information. That's what actually made me go, that's the coolest thing ever. Okay,
I like
doing
it.
That.
I like it. So, wow, what a powerful verification. Yeah. You're going to try and trigger the creation of the tunnel, I'm guessing, with the appropriate traffic. And then thanks to the debug, you'll see the phase 1, phase 2 tunnels get created. You'll see all of it, all the magic happen.
Right. So unless I've done something wrong over on router 2, which is possible, okay? But so the other side, remember that, so like over on router 2, in theory, this should, I actually would have made that R2. I know I highlighted that, which is silly. So you actually see it right here. That should be R2 set. So those are things that we keep consistent on that router is what we do. Now, once we're on the interface, Anthony, what I need to do is actually now attach the map that I just created to the interface. So this should be crypto, and then map, and then I make sure I do R1 map.
And you don't even have to look back for the name because you use that naming convention. And so you know what that name's going to be. And look at that.
Yeah.
So when you tied in the map, we did get some debug output already.
Right. So it looks like it, but it does say that the action is on. So in other words, my access control list, me doing it out of order may have caused some issues.
Yep.
Right? So not exactly sure, but one thing I can do is just do a shutdown here.
Okay, so you're going to recycle the interface.
Try and recycle the interface here. See if that actually is enough to jar it. If not, we'll actually find out what happens next here. I'll do a no shutdown, and let's make sure it comes back up, and then I'll try and issue a ping through this, and we'll see what happens from here. So hopefully that is now up. If I do a ping 2.2.2, and then this is going to be source. I'm going to tell it from loopback 0. And we'll see, and look at that, Anthony.
Wow.
All the information starts coming up as we start seeing it. Everything's actually going through. You want to take the time if you can after this comes, and you see it's a ton.
Yeah.
So Anthony, the overhead in this type of tunnel, you're like, are you joking me? All of that stuff? Yes, okay. All that stuff is going on, is trying to make sure everything is happening. And I see a couple of things here that actually tells me, it says IPsec Security Association has been set. Everything is good. And from this point, Anthony,
wow, that's
it is
so
just
cool.
show Oops.
And you were going to recommend, I think, so when our students try this, you're going to recommend that they actually read through that debug, right?
Right.
They get kind of a running narrative of what's happening.
Yep. So, show IPsec. Oh, I forgot the SA. And this is what you're looking for, which is QM idle, which means quick mode idle. That means it is ready. And notice the status here is active. You see the connection. You see everything. Anthony, if we don't see anything here, what does that normally mean?
Yeah. So we might have gotten our ISACEMP working and we could have checked for that. But that SA keyword is really looking for that security association, which means we've got both of our tunnel mechanisms up and running and it's working. And as Ronnie said, QM idle and active, you're looking for those two variables there.
Yeah. And the other one, of course, is crypto IPsec SA for the security association here. And you can see where it actually is this protected VRF. And you see where it's actually making the connection, the remote and the local identity, the current, it actually is connecting all the way through. And there is that magic port number. I keep highlighting it, even though that's not going to help you out. Port 500, which actually tells us that everything is working. Now, in the end, what we're really hoping for is right here. I don't know why I keep highlighting because I'm expecting to be able to do that. Notice it says packets encrypted, packets decrypted.
Yep.
You know that it's going on both sides.
Right.
Okay?
Those numbers better match.
Those numbers better actually kind of make sure that it's actually going on. So if you actually continue this and you keep sending more traffic through, you should see those increment. And Anthony, that pretty much is it. So remember that the other side is just kind of a mirrored configuration of that. Everything is pretty much identical until that point where you have to go to the peer address and then you have to set that up. But everything else is pretty much identical there.
Cool.
So Anthony, in terms of IPsec tunnel, you saw it all, right? We created the idea of the policy. We set up the encryption key that we're going to share on both sides. We went ahead and set up the IPsec transform set, mapped that all together, as well as set that up on the interface. And you see that it actually did work and showed you a couple of debug commands as well. And
I love it. Well, Ronnie, not to put you on the spot, but I know that you did, for me to have a reference, type this up. Do you mind including this for the
we definitely
learners?
can.
Yeah, that's
no
great.
doubt.
So you can kind of take Ronnie's configuration there, make it your own, get it in on a couple of those routers that you want to test this with, test with the debug, practice, practice, practice. That's great stuff. Well, thank you so much, Ronnie, for leading us on this journey through a path virtualization technique, yet another tool in our tool belt. One that Ronnie said had a lot of overhead associated with it. You wouldn't want to do this when GRE might suffice, but when you want varying levels of security, this is a great option for you. So we're going to sign off till next time in this episode. My name's Anthony Sequeira with IT Pro TV.
And I'm Ronnie Wong.
And we will see you in our next episode here of Encore.
Thank you for watching IT Pro TV.